So let us take this question. So in this question, you're given that f of x is limit n tends to infinity sin x power 2n. So where n belongs to integers. You're asked to find the points of discontinuity of this function. First, here f of x is defined in terms of limit, and the variable of limit is n, and n is in the power. So let us try to analyze this limit. So limit n tends to infinity sin x power 2n is nothing but sin square x whole power n. As n tends to infinity, you have to raise sin square x to the power n. So any number power n, as n tends to infinity, the value depends on what the value of the base is. So this is equal to 0 if sin square x is less than 1. If sin square x is less than 1, if this is a fraction, then as you raise a fraction to a power which is very large, then the number goes to 0. For example, if you take a number 1 by 2 and raise it to power infinity, this becomes 1 by 2 power n, which goes to 0. So if this number is less than 1, then this limit goes to 0. But sin square x is always non-negative because you have a square, so the other limit will be 0 to 1. And this will be 1 if sin square x is exactly equal to 1. If sin square x is exactly equal to 1, exactly 1 power any number is equal to 1. And this is equal to infinity if sin square x value is greater than 1. So these are the conditions. So that means f of x is equal to 0 if, so what is the meaning of sin square x is in between 0 to 1? That means sin x is in between -1 and +1. So there is no equality, sorry, because you don't have equality at 1. So as long as sin x is in between -1 to +1, sin square x is in between 0 to 1, right? So f of x will become 0. And sin square x is equal to 1 means sin x is equal to ±1. So fx is equal to 1, sin x is equal to plus or minus 1. And infinity, if sin square x is greater than 1, this never happens because sin x is always in between -1 to +1. So this case does not arise. So this is my function. And if you think in terms of the values of x, when will sin x be in between -1 and +1? So sin x, when will sin x be equal to +1 or -1? So sin x will be +1 or -1 at odd multiples of pi. So this implies x is equal to 2n plus 1 times pi by 2. So when x is an odd multiple of pi by 2, then sin x will be plus or minus 1, and at those points fx is equal to 1. And at all the remaining values, at all the remaining other values, the value of f of x is equal to 0. Now you are asked to find the points of discontinuity of this function. So as you know, f of x is equal to 0, f of x is equal to 1. They are continuous wherever they are defined because these are constant functions. But if there are some points of discontinuity, they may happen at the boundary points because it is a piecewise defined function. So at all r minus of 2n plus 1 times pi by 2, if the function is continuous. So if at all there are some problems of continuity, they occur at the boundary points. So at the boundary points, as you can see, the functional value is 1, but the limit value is equal to 0. So if you take any point of the form 2n plus 1 times pi by 2, exactly at this point the functional value is equal to 1. But around this point, when x is not equal to 2n plus 1 times pi by 2, the functional value is going to 0. Hence the graph will be something like this. You have a hollow dot here, you have a hollow dot here, and you have 1 here. So hence, as you can very clearly see, fx is discontinuous at all points of the form 2n plus 1 times pi by 2, because the limit value is different from the functional value. So what are the points of discontinuity? X is equal to 2n plus 1 times pi by 2, where n belongs to integers. So that is the answer to this question.